Today we're going to start talking about web scraping, which is the process of writing a program to automatically browse the web on your behalf and to convert online content into structured data that you can then do something with. We're going to start with what I think is the easiest way to do web scraping in Python. This involves using two libraries, one called requests that downloads websites, and the other is called BeautifulSoup, and that helps you parse websites. This technique actually won't work for every single website out there, but it's kind of like a good and easy place to start. So before we start talking about web scraping, we need to talk a bit about HTML, what it is and how it works, and also what CSS is and how CSS is able to style HTML. The reason we're going to do that is that you have to have some base understanding of HTML and CSS in order to use this sort of technique of web scraping. HTML stands for Hypertext Markup Language. It is the language that websites are written in, and it works as a series of elements and tags. So an HTML element is composed of a start tag, some content, and then a close tag. A lot of people use the phrase element and tag interchangeably. I think that's totally fine. I'm going to try to stick to the phrasing of element is an opening tag, some content, and a closing tag, or some tags don't have closing tags, so it could just be the tag. But it's really just you can really use them interchangeably. Here's an example fake HTML element. We have an open tag, some content, and then a closing tag. And just to be clear, the opening tag starts with a less than. We've got the name of the tag, then a greater than sign, then there's some content. And then the closing tag begins with a less than sign, and then there's a forward slash, and then that same tag name again. So this is like a basic HTML element. This is a tag that doesn't exist, so this is a fake one. So let's look at some real ones. The first, probably maybe extremely common one, would be the P tag, which stands for paragraph. This is I am a paragraph. And this denotes that you're writing a paragraph. Some other common tag names would be the body tag. The body tag surrounds the visible content of your website. The H1 tag. The H1 tag stands for header 1, and it creates like a big header, maybe the title of your document. The title. There's also H2, which is a slightly smaller header, maybe a sub header, and then H3, H4, H5, and H6 are all even smaller headers. The A tag is for creating a link. And then a few other really common tags are div, stands for division, and it's just like an arbitrary way of creating little blocks of content inside of HTML. So it's really important that elements can contain other elements. So paragraph tag can have inside of it an A tag, an H1 tag can have an A tag inside of it also. A div tag can have other div tags inside of it. So elements can also have attributes. These are key value pairs that declare extra information about a tag. So some attributes are applicable to any tag, and some attributes are only applicable to specific tags. So for example, the A tag, which is for links, has an attribute called href. So let's write that out. A, and I would write the attribute name href, and then that's the key is href, and then you write an equal sign, and then you put a value in here in quotes. So if I wrote a href equals, and then we put a URL, http, let's say, whitehouse.gov, and then inside, so this is what happens when you click on the link, it'll take you to whitehouse.gov, and then the text of the link you write inside of the tag name. So I would write, say, don't click me, and then I close the tag. So the href attribute is specific to the A tag. You can't give, you could, but it wouldn't mean anything. You couldn't really give an href attribute to say a div tag or a P tag. But there are some attributes that are applicable to all tags, and there's two of these that are really, really important for our purposes being web scraping. And these are the class attribute and the ID attribute. So let's start with ID. The ID attribute gives a unique identifier to a particular element. And you write it by, you can implement it by saying ID equals, and then you just write some alphanumeric series of characters in here. So I can say h1 ID equals, and I could write, say, the title, for example. I am the title. An ID, you can only have only one element can have any given ID. So I can't make other I can't have other elements also have the ID, the title. Just this one element can have it. The other really, really important attribute that we'll be looking a lot at is class. And class is kind of like a user-defined, like the person who made the website, defined category for an element. And again, it's totally arbitrary, but with a class, many different elements can have the same class, and different elements with different tags can also have the same class. So for example, I might have a P tag that has the class important paragraph. I am important. And then I can have another P element with the same class name. I am also important. And finally, I want to mention, and I should have probably mentioned this earlier, is that not all elements have closing tags. So for example, the image tag, which allows you to look at images, opens, but it doesn't close. So I write image, and then I would write src, this is an attribute, equals, let's say, lol capitalism.jpg, and then you just close that that tag like this without actually having a separate closing tag. Okay, so let's look at an extremely bare bones website and what this would look like. At the top, you have HTML. This tag surrounds the entire website. Inside of HTML, you might have a head tag. The head tag contains other tags, or the head element, I should say, contains other elements that are kind of provide like metadata about the page. So for example, the title tag, which is the little text you see at the top of a site that isn't visible in the content, but is visible in your browser. My cool website. And then there's the body tag, and the body tag contains the visible elements of the page. And we might have like a div in here, right? And we might have a title, an H1, let's say. And then you could put like a paragraph tag in here. And then we could just keep putting a few other things in here. We could put a list in here. So the next thing we need to talk about before we get to actual web scraping is CSS, which stands for Cascading Style Sheet. CSS determines the look of a website, both kind of like the position of elements on the screen and particular styles associated with those elements. So like font size, color, background color, all that stuff. We're not actually going to talk about the specifics of CSS styling. It doesn't really matter for our purposes. What we're going to talk about is the syntax that CSS uses to apply styles to particular elements. And the reason we're going to talk about that is we're going to use the same syntax later on to actually do our web scraping. So it's important that you kind of have some idea of what's going on. So a style sheet looks like this. You have a selector. And this is a rule for targeting a specific element or series of elements in your HTML. You have an open squiggly bracket, and then you have a series of rules which are separated by semicolons. So some rule, comma, colon, some value here, and then I could put a semicolon at the end. This is a fake one, right? What we really care about here is the selector, is this bit up here, because this decides how different CSS rules get applied to our page. So let's do a real one. I'm going to delete this. And the most basic CSS selector is just a tag name. So if I want to style every single tag on a page, I write the name of the tag up here, like P, for example. I do an open squiggly, and then I could say color red. And this makes all of our paragraph tags red. You could also style, and this is really, really, really important, classes. So if I say dot and then some class name, like important paragraph, this will style every single element whose class name is important paragraph. So to target a class, you put a dot, and then the name of the class. I can also style IDs, and it's similar but different. I use a hashtag. I say hashtag and then some ID name in here. And this will style every single element, just the single element whose ID is equal to some ID. So again, when you're writing a class name in HTML, you would say class equals and then the class name. When you're styling it in CSS, you just have that same name, but you put a dot before it. And with IDs, it's the same, but except for a dot, it is a hashtag. So tag names is just the tag name. Classes is dot, the name of the class. ID is hashtag, and then the name of the ID. You could also do actually more complex styles. So let's say I wanted to style every single link inside of a paragraph. I could write P and then space A, and it doesn't matter what level inside, just any single, every single A tag that has at some point a parent that's a P tag. And you can also do this with IDs and classes. So I could say style every single, let's do A again, every single A element that is inside of an element whose class name is important. You can also do this with IDs, same syntax. So something space something means the second thing gets styled if it is inside of a selector that matches the first thing. And you can go as far down as you want to. So if I added a span to this, this would say style spans that are inside of A tags that are inside of class names whose class is important. Finally, you can also style multiple things at once if you separate them, the selectors by commas. So if I wanted to style H1, H2s, and H3s, I could say H1, comma, H2, comma, H3. And you could mix and match again. You don't have to just stick to tag names. You can mix and match IDs, classes, and tag names, or any selectors that you want. So we're finally basically sort of ready to talk about web scraping now. I think we have enough of the kind of essential tools that we'll need to get going. We're going to be doing web scraping in Python, and it's possible to use Python's built-in tools to do web scraping, although I find it much, much easier to use some external libraries to kind of help us out. So the two libraries that we're going to be working with are called requests and BeautifulSoup. And before we use them, they're not part of Python, so we have to install them. I'm going to open up my terminal to do this. Here's our terminal. There are different ways. There are actually a lot of different ways of installing Python packages. I'm going to do the easiest thing, which is not necessarily the correct thing, but it is the easiest thing to kind of get going, and that is to install our packages in our home folder. Usually what you'd actually want to do is to create what's called a virtual environment and install packages inside of that virtual environment, and then you have a different virtual environment for each project that you're making, but I think it's a little bit too much for now, so we're just going to use the kind of global user installation. We're going to use Python's package manager, which is called pip. So you're going to type pip, and it's a little weird, but you're going to type pip3 probably, not pip. You're probably going to type pip3 because there's a version of pip that's for Python 2 and another version that's for Python 3. So you're going to type pip3 install, and then the word requests. Pip3 install requests. And mine was already installed. So when I did that, it just said it's already been installed. Don't worry about it. And then the second thing you're going to install is BeautifulSoup 4. So pip3 install BeautifulSoup 4. And again, mine was already installed, so it just happened. Yours will take slightly longer, but not too much longer. The next thing that we're going to do is I just want to navigate to some folder where we can actually put our examples. So I'm going to do mine on the desktop. I'm going to go cd desktop, and then I'm going to make a new folder called scraping examples, and I'll just call it 1 because this is like our first scraping examples. And then I'm going to cd into that folder, cd scraping examples 1. Now, let's make a file, and I think the first thing that we're going to scrape is the New York Times. Let's do a quick New York Times example. There's no particular reason we're doing the Times. It's just an easy first example. So I'm actually going to go back to Visual Studio Code. I'm going to make a new file. Before I even put anything in it, I'm just going to save it. I'm going to save it in the desktop inside of scraping example 1, and I'll call this one nytimes.py. Don't forget to put the py. Okay. Now, before we do anything else, we need to import the libraries that we just installed with pip. And to do that, we're going to type import requests. That allows us to use the request library. And then from, and this is a little weird, from BS4, like that, import, and then capital B, beautiful, capital S, soup. So web scraping involves 2 steps, right? You have to download the website that you're scraping, and then you have to parse its HTML and pull out things that are of interest to you. So let's start with the downloading step. I'm gonna type, I'll say r equals requests.get, and then open parentheses, and then in quotes, the name of a website that I want to retrieve. And we're going to use, like I said, we're going to use the New York Times. So I'm going to write in here https://nytimes.com. So r equals request.get https nytimes.com. And what this is going to do is it's actually going to go to the New York Times website, and it's going to download the content of the front page of the website. We can actually see what that content is if I print r.text. So let's go ahead. I'm going to save this, and let's go ahead and run this in the terminal and make sure that it actually did what we expected it to do. So I'm going to go back over to my terminal. I'll just resize this so that we kind of can see everything at the same time. And I'm going to write Python 3 space nytimes.py. And then I'm going to hit enter, and what we'll see is hopefully it's a big mess, but if I scroll up, it's a big old mess. If I scroll up, you'll see the rather huge New York Times front page. Now, what we're seeing over here on the left is actually the same as if, and let's go ahead and do this. I'm going to go to Chrome. I'm going to make a new window, and I'm going to go to nytimes.com. And what I'll see on the terminal is the same thing as if I went and did view developer view source. So web scraping is possible because HTML is an open language, the web is an open platform, and every single thing on the internet, not on the internet, every single thing on the web, you can look at the source code of, right? So you can see how it's made, and that this fundamental quality of the web is what allows us to do web scraping. So just to prove that it's the same thing, if I scroll all the way to the bottom here and look, down here, I should see that this very bottom thing here is exactly the same, hopefully, as what got printed out in the terminal over here. Okay. So let's go back to the New York Times. And what we want to do for this very, very first baby example is I just want to print out on the terminal all of the headlines from the New York Times. So the question is, how do I do that? And the way that we're going to start understanding how to do that is by using a special tool called the Web Inspector. Now, I'm going to use Chrome for this. You don't have to use Chrome. You could use Firefox, you can use Safari, you can use Internet Explorer, maybe, I don't know. The tools should hopefully be about the same in all of the browsers. But I actually use Firefox usually, but I'm going to use Chrome because I feel like most people are using Chrome, and it's just sort of like the more standard option. Okay, so what we're going to do is we want to get the headlines, the New York Times headlines. So how are we going to do that? We have to figure out what tags the headlines are in, or what CSS classes or what IDs the headlines are related to. So to do that, I right-click on any element in the page, and I go down to Inspect. I click Inspect, and then what you'll see pop up is something. It might not look exactly like this on your computer, but it'll be something that looks like this. You'll see a series of elements. You'll see the source code for the page, and in it will be a series of elements. Now, I'll make this a little bit bigger, so hopefully you can see it okay. I'll also just drag this down so it's a little more obvious. Okay. So what I see over here is the source code. As I mouse over different elements in the source code, those elements will be highlighted in the page to the left. So I can see here that this China moves to impose new Hong Kong security laws, tightening control. This is inside of a span. That span is inside of an H2 that has a really crazy looking class name. That H2 is inside of a div. Div is inside of an A tag. The A tag is inside of another div, which is inside of another div, which is inside of an article. Okay? And also, I can kind of handle it. I can like open and close these different tags over here, or these different elements, I should say. So I'm just going to say that what we need to do is we need to figure out what the CSS selector is that's going to get the exact elements that we need, right? Now, and sort of the easiest way to do this is to right-click and do inspect on a few different elements in the page. So I'm going to go, okay, so we did this one. Let's look at another one. I'm going to right-click on this guy over here, and I'm going to do inspect now over here. And now I'll see that this is also an H2, right? Let's do another one. I'll right-click on this one. I'll do inspect. Oh, look, here's an H2 also. And again, with this crazy class, in this particular case, I'm going to guess that the H2 element is containing all of the headlines. I'm actually not 100% sure yet, but I think that's a pretty good guess. So, you can keep going. I could do this for spy agencies, briefing, blah, blah, blah. I'll right-click, inspect. Oh, look, it's another H2. By the way, I could also use a different way of doing this is up here. It says, if I mouse over this guy right over here, it says, select an element in the page to inspect it. So I can actually click this, and then I can also mouse over different elements, and I will see their code over in the right. So this one's an H3, this one is an H2, H2. That one's a span, but there's an H, it's inside of an H2. Okay, so I'm going to say that H2 is the element that we need. I could be wrong, but I'm going to guess that H2 is the element that we need. So now we're going to go back to Python. I'm going to go back over to Visual Studio Code. And what I need to do is I need to stick this HTML, I need to feed this HTML to BeautifulSoup. BeautifulSoup is a library that helps us process and parse and analyze HTML. So I'm going to make a BeautifulSoup object. We're going to call it soup. It'll say soup equals, and then I write BeautifulSoup, open parentheses, and then I give it some HTML. And so the HTML of the New York Times is coming from r.text, so I'm going to write r.text. And now what I have is this this beautiful soup object. What is it? What does that mean? I don't, let's not worry about it for a second, but I have this beautiful soup object that is encapsulating the HTML of the New York Times. And what I can do with it is I can extract elements from this soup object using their CSS selectors. To do that, I use a method called select. So I could say titles equals soup.select, open parentheses, and then in quotes, and now I can put any CSS selector I want to. So for example, I could write H2. And what this will do is it'll take all of the H2 elements on that page and stick them into a Python list that's called titles. So if I just go ahead, first of all, I'm going to delete this print r.text at the top here because it's going to distract us if I do that. And I'm just going to go ahead and for now, print titles, just so that we can see what happens. I'm going to go back to the terminal, and I'm going to run this code. And it's all very confusing. It doesn't really, it looks like a mess, but we can sort of see that this is a list of different H2 elements. There's one. Here is the next one. What we need to do next is we need to go through every single element in our titles list and just print out not the full HTML of that element, but just the text of it, right? Just like the actual text content of the element. So we can do that with a for loop. We can say for, and let's just say t in titles, colon, and then to print out just the text of an HTML element using BeautifulSoup, we used the text attribute. So we say for t in titles, print t dot text. And that's it. Now I'm going to go back over to my terminal, and I'll type again. I'll clear this for a second. I'll type Python 3 nytimes.py. I'll hit enter. And what we'll get is all of the headlines. We're also getting some other stuff that's not a headline that's wrapped in an H2 tag, like site indexed and site information navigation. But we're just going to ignore that for now and say that this is a good enough example. So again, what we did is we imported requests, we imported BeautifulSoup, we grabbed the HTML of the New York Times using requests.get, which we stored that inside of a variable that we've here called R. We made a BeautifulSoup object using the text of our request, and then we used the select method to get all of the H2 elements and put them into a list called titles. Now, like I said, we could use any CSS selector in here. So, for example, if I wanted to get all of the links to all of the articles rather than the titles, I could do something like this. I could say links equals soup.select, and then I can put in the A tag, A, and this has to be in quotes. And then I could say for L in links, print. Now here's the question. If I want to print the text of the links, I would say print l.text again, right? That prints the text of the links. I'm going to clear this, and I'm going to actually just comment this out for a second because we're not going to use it. If I want to get the URLs of all the links, I need to access the attributes of our tag, because href, which is actually what stores the link, is an attribute of our A tag, right? And to get an attribute using BeautifulSoup, I can actually type l.get and then open parentheses and then in quotes the name of the attribute. So if I say l.get href, it will grab for us all of the href attributes for all of the links. So now if I run this again, we should see that we get all of the URLs. So I'm going to do one more example, and this next example is about using BeautifulSoup in requests to not just get items off of a single page, but to iterate through a bunch of links and get a bunch of data from all those different links. So let's look at another kind of classic web scraping example, which is Craigslist. I'm going to go to craigslist.org, and I'll actually close this for a second. Let's make it a little bit bigger. Craigslist is it's a really nice place to scrape. Actually, my favorite Craigslist category, but we're not going to scrape it right now. My favorite Craigslist category is the barter category. Trade your unused bicycle for a small snowblower. Super awesome. Keyboards and speakers for office phones. Amazing. Okay, so anyway, I don't want to do that right now. What instead I want to do is I want to actually scrape the jobs listing. I think it's May 2020 right now. The coronavirus has obviously deeply impacted the job market, and I'm curious if there's anything we can learn about what's going on in the world based on the jobs that are being posted on Craigslist. So what I'd like to do is I want to write a script that goes through all of these different job boards and just tells me how many jobs are being posted in each of the different job boards. So for example, I just clicked on accounting and finance, and I can see that there are 118 accounting and finance jobs being listed. If I go, on the other hand, to art, media, design, there's 63 jobs listed, right? Now, of course, this is not going to be a very scientific endeavor, right? Because I don't have any data about job listings on Craigslist before the pandemic, but I still think it might be, this could be still sort of like an interesting project to do right in this moment. So in order to do this, what I need to do is our script, our program that we write, needs to first go to the front page of Craigslist. It then needs to find the URLs for every single one of these job links. It needs to effectively click on this link, right? It needs to click on the link, and then it needs to find this element right here that lists the total number of jobs. So let's start this. And we're going to start exactly the way we started the last little task. We're going to right-click or control-click on one of these elements, and then I'm going to go down to Inspect. And I'm going to see that this element here is a span. This class is text, not too useful, but it's inside of an A tag, right? This A tag actually has the URL to the job board in it, right? That A tag is inside of an LI, that LI is inside of a UL. This is interesting. That UL is inside of a div called, whose class is cats. And finally, if we go up 1 or 2 or 3 more, we can see that we are inside of a div whose class is jobs. So if I wanted to get all of the A tags, what I need to do is make a CSS selector, right, that looks for jobs. It then looks for cats, or actually this, here we go. Sorry, this is better. It looks for a UL whose ID is JJJ0, and then it looks for all of the A links inside of that. I think that's what's going to do it. So let's start with getting all of those URLs, and then we can do the thing of going to the next page in a second. So I'm going to go back to Visual Studio Code. I'm going to make a new file. I'm going to save this as we'll just save it in the same folder, craigslistjobs.py. And we're going to start exactly the way we started last time. I'm going to import requests. I will then import, from BS4, import BeautifulSoup. And then we're going to use requests to grab the HTML of newyork.craigslist.org. So I'll say r equals requests.get, and then in quotes, now let's copy that, right? And then I'll say soup equals BeautifulSoup, open parentheses, r.txt. And then we need to get those URLs. So what I'm going to say is I guess I'll call it links equals soup.select. And then now's the tricky bit. Let's figure it out. So again, we're in, I think this is the easiest way. We're in a UL whose ID is JJJ0. Okay, So to grab something by a particular ID, I use hashtag, and then I write JJJ0, and that'll get me that whole unordered list element. But what I actually want are the links inside of it, the A tags inside of it. So I do JJJ0 space A, and I think this will do it. So let's just to start, just to make sure that things are working, let's go for link, let's say L, in links, colon, and then let's just print out, the text. We'll say job, and maybe store it in a variable. Job cat for category equals L dot text, and then let's print job cat. Okay. So if I run this in the terminal, I'll clear first. Python 3 Craigslist jobs.py. I hit enter, and I'm getting an error, but we'll come back to that. We see that we get accounting and finance, admin office, engineer. It looks like it's working. So this error was probably coming up before, and I just didn't notice it in my haze or whatever. It says no parser was. Let's just look at this a little bit bigger. No parser. Craigslist user warning. No parser was explicitly specified, so I'm using the best available HTML parser for the system, LXML. Okay. Yours actually might say something a little bit different. Yours might say HTML.parser in here instead. And what's going on here is that BeautifulSoup is taking the HTML and wrapping it into an object that allows us to easily navigate that HTML, but it's using another it's using another library to do the thing of parsing the HTML. And BeautifulSoup allows you to pick what kind of HTML parser you want to use, because there's actually a number of them. There's actually a lot of different ways of taking that text, that HTML text, and translating it into something that Python can understand, right? Translating that HTML text into some kind of Python object or data structure. So BeautifulSoup is giving us a warning when we haven't specified which parser we want to use. And it's actually fine. We could delete this warning. We could get rid of this warning if we just specify our parser. So I'm just going to go ahead and do that. In this BeautifulSoup object, I'm going to write comma, and I'm going to write HTML.parser. You could actually ignore this and it would be fine, but it's annoying to see this error, so we're just going to do this, HTML parser. And I'm just going to run it again to see if that did actually get rid of the error. And it did, so lovely. That's better. Okay, so now we have the names of all of these job categories. We're also going to need the URLs, right? So I'm going to say job URL equals L, and if we remember to get an attribute from a soup object, we say L and then dot get, L.get, open parentheses, and then the name of the attribute that we're looking for, in this case, href. So now let's print job cat and job URL and make sure that this still works. Great. So it is working. However, you'll notice that we got the name, accounting and finance, but then the URL isn't actually the full URL, right? To Craigslist. It's just the partial URL. It's the bit after Craigslist.org. So what I actually want to do is we're going to need that full URL. So what I'm going to do is down here, I'm going to say job URL equals, and then we're going to do some string concatenation. And I'm just going to go ahead and I'm just going to copy this bit, and I'm going to say that whole Craigslist bit plus L.get href. We could have also stored this into a variable, which is probably what we should have done, and then reference the variable both for our GET request and our little string concatenation down here, but I think it's basically fine. Okay, so save this one more time. Let's run it. Okay, great. We're getting the name of the job category, and then the actual URL. Right? So now let's figure out how we can get the that total number of jobs in those categories. I'm going to go back to Craigslist, and I'm just going to go ahead and click on any one of these. And then I can see that this is the number here that actually, this is the number that I want. So again, I right click on this number, I click inspect. And then Craigslist is making things really easy for us because it's actually put this 404 number inside of a HTML element whose class is total count. Okay. So let's go ahead and add this back in. What we're going to need to do next is, well, it's a two-step process. First, we've got the job cat and job URL. I'm going to not print these out for a second. I'll just hide that for a second. We're going to make a new requests object that gets this job URL. Okay, so I'll say r equals requests.get job URL. And then we're going to make another BeautifulSoup object that stores that represents the HTML of these individual job pages. So I'll say soup equals, and I don't know if I want to make a new, you can use the same name that you used before, but then if we wanted to later in the script do something with our original HTML, it'll get weird. So maybe we'll just call it soup2, okay, equals soup2 equals BeautifulSoup r.text, and again I'm going to write HTML parser so we don't get that stupid error. I'm going to use again that select method to just get that total count class. So I'll say total equals soup2 dot select dot total count. And now what I'm going to do, actually I will uncomment this, is I'm going to say print jobcat job URL, and actually something is wrong because total, right? If we soup.select always returns a list. It always returns a list of objects, right? A list of elements rather. And even if there's only one thing that we're looking for, it's going to return a list for us. So actually there's another BeautifulSoup method that we're going to use called select1. And select1 does the same thing as select, except it just returns the first element that matches that CSS query, right? That CSS selector. So select1 is just going to return one object for us. And then we'll say select1 total count dot text, just like that. Okay. Now I'll print jobcat. Let's get rid of the job URL and total. I'm going to save this, and I'm going to go back to our terminal, and I'm going to clear, and I'm going to run it again. And we'll see that we're getting the total number of job listings for every single category in Craigslist. Now there's two things that I'm just going to add on to this, and then I think we'll be done with this example. Right now what we're doing is we're just making a bunch of requests one after the other, right? Get this page, then get this page, then get this page, then get this page. It's sometimes better for two reasons to put a little break in between each request that you're making to a particular server. And the two reasons are, one, it's kind of, I guess you could say, politeness. It's just a little bit nicer for the people who make the website if you're not hitting them really hard. And the other, which is a more pragmatic reason, which is it's simply that when you write these web scraping bots, sometimes you'll get blocked if you make too many requests all at once. So both for the sake of politeness and for the sake of pragmatism, it's good to put a little bit of a little break in between each of your requests. So to do that, we can use a built-in Python module called time. I write import time. And then time has a method in it called sleep. And sleep just like puts your script to bed. It just says, don't do anything for a certain number of seconds, right? So what we can do is after we print this job cat and total, I can write time.sleep and then in seconds how long I want to sleep for. So even just putting in like a little bit of time, like a fifth of a second or half a second here, can make a big difference in terms of A, not getting blocked, and B, being, as I say, being a little bit polite. So we'll say time.sleep for 0.4 seconds. Okay. And now if I run this again, we barely notice the difference, but it is kind of, it's resting a little bit. The other thing I'm going to say here is, what if I wanted to stop this script while it was still running? I can, right? Like I was like, I just don't want it to run. I can type Control and C, and that will interrupt the script from running. The very last thing, which is, what if I want to save this stuff to a file? So I can type Python3 craigslistjobs.py, and then I can type the greater than sign, and then space, and then I can just give it the name of a file I want it to save the output of our script to. So I could just save this as jobs.txt and hit enter. And it's it's hard to see. I'll just make that bigger. So I write the name of the script and then the greater than sign and then some file name. And if that file exists, it will get overwritten. If it doesn't exist, it will be created. And let's hit enter. And now I won't see anything on the output because the output of our script is going to this file. Okay, it finished. So if I type ls, I should see now that I also have a jobs.txt file in here. And if I type more jobs.txt and hit enter, here we go. Here are all of our jobs. So I think that's it for today's lesson. Thanks for watching. Let me know if you have any comments, questions, or suggestions. I will be posting new videos very soon.